Let's look at some very specific rules for logarithms. So we just talked about in a previous video some of these pretty generic properties that aren't necessary. I mean, we can call them properties, but they're really shortcuts for evaluating very specific types of singular logarithms. Now, inside these logs, we had one, we had a. This one was a logarithm raised to a power. This one had a power on the inside of the logarithm. Okay. What we're going to focus on here is three different types of scenarios where we have values, quote unquote, inside the logarithm. So this is called the product rule. Okay, now parentheses with logarithms are really important because they tell us what's actually inside the logarithmic function, right? And when we have a product like so, we like to put parentheses around it. You don't necessarily have to have parentheses around the product because we're dealing with this as one package, okay? But the product rule for logarithms states that if inside a logarithm there is a product, that can be written as the sum of two logarithms. Okay. So what I like to say is the log of a product, the singular log of a product is means equals, right? The sum of two logs. Okay. Or let's just say the sum of logs. Okay. So we basically take the two parts of that product, we separate them. Okay. And we put each one of those inside its own logarithm. And if you're wondering, like, well, why is this possible? Why does this work? Remember what we said about logarithms from day one. What are logarithms? Logarithms are exponents, right? So you had an exponent property that said if you take the product of two the product of two powers that have similar bases, what do you do to the exponents? You add them, right? So here we are taking a product and turning it into a sum. So because logarithms are exponents, we are using exponential properties with these logarithms. Okay. Now, even though we write this in this fashion, this is really a biconditional. This goes both ways, right? So there are times, and we'll get to this later on, where we want to take the sum of two logarithms and create the log of one product. Okay. But what's key about this is you understand the reason this works is because logarithms are exponents, right? And exponential products become sums. So that's what we're doing here. All right. Here's one example. So we have a log with no base. Remember that this is a common log. So this is really log base 10. And inside this logarithm, we have the product of 10,000 and y. All right. So the words that we're going to start to see here are expand. And when we talk about expansion, which we're going to deal with in more detail in a future topic, in a future lesson, but you're going to start to see the words expand. Okay. Which means this logarithm that has a product on the inside can become two logs where I separate the product. Find that breaking point where the product exists, where that multiplication exists, and then write two separate logs. Okay, now I'm not writing the 10 here, and I probably won't, okay, because I want you to get used to seeing this common log as log base 10. But once we get to this point, look inside this log, right? This is a common log of 10,000. And since there are no variables here, we should make an attempt to evaluate this without a calculator. And how many videos have we done, and how many videos have you seen? How many problems have we gone through where we said, we're asking the question, what power do I raise this base to get this number, right? So off to the side, 10 to the something power is equal to 10,000, right? Well, 10 to the first power is 10, 10 squared is 100, 10 cubed is 1,000. So this is 10 to the fourth power. So this logarithm has a value of 4. And I'm going to evaluate that. As long as I can do it without a calculator, I'm going to do that. This is a variable expression here, so I can't raise 10 to some power and get y. But I can raise 10 to the fourth power and get 10,000. Okay, so this is what that expansion would look like after we evaluate that first part.